Greetings. In this video, I want to talk about file systems on storage drives and the necessity of partitioning and of low-level formatting. One of the major issues about switching to Linux is too much choice. Covered this in an earlier video, and this unfortunately is true of file systems also. In Windows, it's easy. NTFS, or New Technology File Systems, or FAT, File Allocation Table, both of which are Microsoft proprietary formats. In Linux, not so easy. You've got EXT, BRTFS, XFS, ZFS, LVM, to mention a few in the large array of file systems, and this doesn't even include NTFS and FAT, which Linux can also read. So the question for new users is, which file system do I actually use? Well, maybe not, as some beginner-friendly Linux distributions, or as I'm going to call them the rest of this video, distros, have built-in defaults, and if you stick with the defaults, you usually don't go wrong. But it does really depend on your needs and how adventurous you are. For simplicity, for the new Linux user, let your distro decide not only the file system, but how to partition your drive. Like I say, most distros have reasonable defaults for new users, and if you're the average user coming from Windows, you're probably not going to be overly interested in how the drive's partitioned or how the file system's set up. But to be clear, there is no one golden file system for everyone. In spite of what the many fanboys on the internet tell you, every file system has its own advantages and disadvantages. And depending on your use case, some might even be impractical. I did mention partitioning. File systems do not sit directly on your drive. Rather, they sit on a partition on your drive. And in some cases, they sit in a logical volume on top of a partition on top of your drive, but we'll get into that. And partitions sit on top of the low-level drive format. And there is more than one partition scheme. Well, in this case, there's only two. Well, two for the majority of computer users nowadays, so that one's not really much of a choice. And we'll get into that too. And some file systems include their own partitioning schemes, which complicates the issues in some ways. And then there are multiple drive arrays, or RAID, for a redundant array of inexpensive drives, to add to the confusion. It's not my intention to tell you what file system, drive arrangement, or partitioning scheme to use. Rather, I hope to impart enough information for you to make a semi-informed decision based on your use case. And if you're a new user or new to Linux coming from Windows, let your distro decide for you. That's the best advice I can give you, and once you know more, you can make your own decisions. I will mention that this video is going to be more theoretical, techie, not any real computer work. Once I get through this, and the next video will probably involve actually partitioning and setting up file systems on a hard drive, but not this video. This video, we're just going to talk about it, and we're going to try and give you the information you need to make an informed decision. So let's get to it. Okay, it's probably the best to start at the beginning and work up from there. I want to be clear, like I said, I wanted to be clear up front, this is all theoretical. Actual hands-on will come in a later video, so if you either already understand the theory or are not interested in it, feel free to skip this video. However, I do suggest that if you are new to Linux or computers in general, you take the time to watch, and we go over some very fundamental concepts that apply to Windows as well as Mac and Linux. I mean, you can use your computer regardless of the operating system with a minimal understanding of some of this stuff, but the more you get into it, at some time you're going to need more than basic concepts. Otherwise, after you've used your computer for a while, if you use it on a regular basis, some of these concepts can turn around and bite you. With a little basic knowledge, you can fix 85% of problems you are likely to encounter, and again, this is regardless of your operating system. Generally, before actually installing anything, your installer resides in memory up to the point you actually put a file system on a drive someplace. You need to partition and format your drives. I know if you buy a laptop or a computer directly from a manufacturer, it comes with Windows pre-installed, you don't have to do that. But if you're reviving an old computer or you're adventurous, even if you want to reinstall Windows, you'll be doing that. In the old days, it was fairly simple. There was one scheme, and low-level formatting was based on your disk controller for your operating system. Of course, that was back in the days when 10 megabyte hard drives were considered big. Today, it is a bit less clear as there are alternate partitioning schemes and many file systems to choose from. For example, today you can partition your drive directly, or you can use a volume manager for virtualized storage, installing an additional level of complexity that provides some useful features, but also has some downsides. For example, something we're going to talk about called LVM, or Logical Volume Manager, can make multiple drives look like a single large drive, but one should be aware there are pitfalls to this method as well as advantages. Speaking of combining drives, we also mentioned RAID, or redundant array of inexpensive disks, is another term you will hear with regard to virtualization of storage. We're not going to be discussing that in any detail, mainly because, again, our target audience for these videos is the new users and people just switching from Windows average users. We'll start our discussion with a new disk, then move to partitioning, and then installing a file system. We will talk about virtualization also. This can be a bit confusing as some file systems do all three of the above. We will also look at the merits and pitfalls of various popular file systems, at least the ones I've used. Like I said, there's a lot of them. I'm going to mention some of them, but I haven't actually used them. And like I say, what you do is going to depend on your use case. A web server running hundreds of clients or a game server with multiple disk arrays is significantly different from your personal laptop with just a single storage drive, and it will require different partitioning schemes and different file system layouts. Again, your use case. For this video, I'm going to stay away from the difference between mechanical and solid-state drives other than speed of access. Yes, there are differences in the technologies. Like, for example, when you hear the word sector, that refers to a mechanical hard drive, which sector is on a track, which is on a platter. These don't really exist in solid-state drives. Block is probably a more accurate term. But again, it's not really relevant to what we're discussing here. And in tune with the fact that this is a series on switching to Linux for the average user, we will mainly focus on drive configurations that a current Windows user might have on their personal PC. Off we go to the races, and hopefully you'll enjoy this video. Oh, and I guess I'm supposed to mention this: subscribe, like, comment. Thank you. Our first subject, file system functionality, or what do you expect from your file system? So your basic file system functions are to store your data, name and location. To manage your data, again, you have a certain structure. You have files, you have folders, you have subfolders. Edit your files, access them, update them, save them, even delete them, which I probably should have added there. Again, those are your basic functions that every file system should have. Most modern day file systems have some advanced functionality built in. Error checking correction through processes such as checksums, journaling, parity, etc. Access control with users, groups, and various permissions. And protection, security, and encryption. These first two are the hallmark of most modern day file systems. Some file systems also offer volume management functionality, or you can achieve this through additional software. This includes managing and combining multiple drives or partitions. Things like data snapshots, which allow you to return to a previous state. Resizing partitions is generally easier in a volume management, and then fault tolerance with things like RAID. Again, we'll be talking about a lot of this stuff a little more, but what you actually need from your file system will really depend on your use case. Next, we need to talk about preparing your drive. So as I said, there are two schemes. One of them is going away. It's MBR, master boot record, and GPT are the partitioning schemes. Currently, either one of these two schemes are used across most computers. They determine how partitions will be laid out on your drive. Master boot record, or MBR, is the oldest of the methods. Boot data is stored in the first sector or block of your drive. Again, remember, sector, mechanical drive, block, solid state drive. Yeah. The problem with this method was there's limited space because the sector is only so big. Some of the limitations were 4 primary partitions, although you could extend this with logical partitions by sacrificing one of your primary partitions, and there was a 2 terabyte size restriction. GPT is the newer method of partitioning. Boot data is stored in an EFI partition, and the partition can be basically any size you want. It's much larger than a boot sector. GPT does use the first few sectors of a hard drive for its partitioning table. Meaning that it's using more than one sector, you can have up to 128 partitions. And the size limit for GPT is 18 exabytes. If I remember my math correctly, an exabyte is 1 million terabytes. Yeah, I think that's right. Anyway, somebody can look that up and check me. Support for additional programs you may or may not want also come along with a GPT, like secure boot and various encryption options. If you're really interested, I did a video, see my video, PC boot past and present. I'll leave a link above my head someplace. Yeah, there it is. Okay. Anyway, if you're really interested, you can go take a look at that video. Now it's time to talk about storage drives. So when you bought a storage drive, it probably already came partitioned with some sort of a file system already on it, but we're going to assume you redid your storage drive, so we're going to start from blank. Later, we'll talk about seeing what's on your drive. First thing that we have to have on our drive is a low-level format. This is usually done at the factory. Like they say in the old days when you had disk controllers, it was done on your computer, but nowadays it's only done in the factory. You'll see some factories advertise low-level formatting programs, but in reality, these are reinitialization programs that bring the hard drive back to factory defaults. They don't do a low-level format, at least not in most cases or any of the ones I've run across. Next, you're going to decide whether you're going to go GPT or MBR. As I said, MBR uses the first sector of the drive as a bootloader. Well, stage one anyways, or at least it looks for the stage one. But MBR is the older system. If your computer is new or not more than 4 or 5 years old, you're probably using GPT instead. If you're working with very old computers, yeah, you might run into MBR. As I said earlier, GPT uses the first several sectors of the hard drive and where it holds its partition table, being bigger than a single sector. That's why you can have a larger partition table. And if you're using GPT, the next thing you're going to need is an EFI partition. This is an actual partition, like I said earlier, and it can be any size. I generally make mine about 512 megabytes, although I remember early days of Windows, it was only 100 megabytes, and then I think Fedora defaults to 600 and some megabytes. It's where all your bootloaders actually reside in the EFI partition, which you can then add additional partitions to your drive, as many as will fit up to 128 if you're using EFI. Note I list partition 2, partition 3 because EFI is a partition, so it would be partition 1. I should also note that your partitions can really be on any order in the drive. Your EFI doesn't have to be the first partition, it can go wherever. Once you've laid out a few partitions, you can lay a file system on top. NTFS or for Windows, or maybe ext4 for Linux. It's going to depend on your operating system, but these sit on top of your partitions. You need to partition before you can install a file system. And you can go ahead and add additional partitions up to the full size of your storage drive. One more thing before leaving this section, your EFI partition must be in a file allocation table or FAT. That's a requirement, and it must be on your hard drive. It can't be in a RAID array or a logical volume or anything like that. I'd better mention that before moving on. Okay, let's talk about partitioning. And I don't mean actually creating the partitions, that's for a future video. What I mean is, what partitions do you absolutely need? And what partitions are not necessarily needed. Every operating system uses partitions, even Windows, you just can't see them. MBR uses a boot block and does not require an additional partition. GPT requires an EFI system partition, so if you're using GPT, you require an EFI partition, and at a minimum, you will need a partition for your operating system, at a minimum. At a minimum, 1 partition MBR, 2 partitions GPT. Other standard partitions you may have, if you have a Windows system, you may have a 16 megabyte Microsoft Reserve partition on your hard drive someplace. You're using Linux, you may have 1 or more optional swap partitions someplace. And a lot of people like to separate their data from their system, so you may have a separate home partition. These are all fairly common types, and we'll actually do an example that uses all of these. And if you buy your computer from a manufacturer that comes pre-installed and you don't get a recovery CD or USB, you're probably going to have a recovery partition someplace. Again, we'll get into that. Additional partition types, depending on your system, your purpose, your needs. Like I say, a web server has a different partition need than a laptop computer. Oh, there's a manufacturer's recovery partition. That if you install Windows directly downloaded from Microsoft, you will not have that. Generally, if you buy a computer pre-installed, you're going to have that. You may want a separate games partition. I see some people do that. Or depending on if you're doing virtual machines and whether you're using a type 1 or type 2 hypervisor, you may also want additional partitions for virtual machines. Again, the only two partitions you really need on GPT system are an EFI and an operating system partition. And if in doubt, let your distro's default rule until you understand things a little better. And again, I need to mention sum of partitions not to exceed your drive space. It's in most cases, like I say, with the one exception I do know about, this can't happen, but just be aware. I mentioned Logical Volume Manager, LVM, earlier. This is one of several virtual disk management. I've got a quick example up here. Let's say you've got 2 hard drives. You've got your EFI partition because it's a modern computer using GPT. We're using Linux, so we got a couple of swap partitions. Then we'll create partitions that fill up the rest of our drives. On drive 1 will be physical volume 1. On drive 2, it'll be physical volume 2. You'll do this with the Logical Volume Manager tool. And once that's done, you can combine PV1 and PV2 into a volume group. So if we had a 0.9 terabyte partition on PV1 and a 1.9 terabyte partition on PV2, our volume group would be 2.8 terabytes. There's a little overhead in there, but about that. Then using a Logical Volume Manager, you can stick partitions, which are actually called logical volume, on top of your volume group. And you can put as many, again, as you have space in your volume group. LVM will take care of distributing it between your 2 drives through the volume group. One of the advantages of something like LVM is you don't necessarily waste a lot of disk space by trying to pre-guess how to partition things. You can expand and contract partitions fairly easily, and you can combine all your drive space into one continuous block of space. Since we're assuming you're coming from Windows, let's talk about the default file systems in Windows. I've got 2 listed here. There's a third one, but it's only generally used on servers. So file allocation table, or as a lot of people refer to it as FAT. I don't know if that's politically correct or not. This is the older technology. It started in MS-DOS way back in 1977, and it was used up through the Windows 9X series. That's 95 and Windows 98. The original file allocation table was 8 bits, had 8-bit address buses. As the size of drives increased, the address bus size had to increase, so we ended up with FAT12, FAT16, FAT32, and the final version is exFAT. This is a really basic file system, no journaling, no encryption, permissions, or security features. It's actually supported by pretty much any operating system out there, including Linux. Some limits in file size and drive size, and this mainly has to do with the address table size. As I mentioned previously, EFI partition is required to be FAT. Usually this will be FAT32, or at least that's what I use. The newer file system from Windows is NTFS, or New Technology File System. Microsoft proprietary file system used on Windows NT, Windows XP, and later that includes Windows 7, Windows 8, Windows Vista, Windows 10, etc. It supports journaling. I keep saying journaling. Journaling is a method of, to increase hard drive speed. Things are not always written right away. They're kept in memory. Journaling keeps track of what's supposed to be written, what's not supposed to be written to the drive. And in case of things like power failures, when you bring the power back on, the operating system can look at the journal, it uses a circular journal, can look at the journal and figure out what it was supposed to be doing, and generally resolve most of any corruptions or conflicts. Incidentally, because files are kept in memory, not written right away, this is why you need to use your operating system to eject a USB drive rather than pulling it out to avoid corruption of unwritten files. But yeah, journaling helps reduce incidents of corruption. NTFS also supports permissions, security, and encryption. It's not as compatible as FAT with other operating systems. For example, while there is an NTFS module, I think in the Linux kernel, you need additional software to make use of it. One disadvantage of the NTFS file system is if it's not properly secured, then anybody else, when you boot up in a different operating system, will only be able to access it read-only. This is more important if you're dual booting, as I've seen this problem several times. Windows NT and later systems will be using NTFS by default. Other drives accessed by Windows can be either NTFS or FAT. And what I mean by access by Windows is they'll show up as a separate drive in your file manager, drive C, drive D, drive E, etc. All right, let's talk about Linux file systems since we're assuming you're trying to migrate there. There are no default Linux file systems. Linux can use multiple file system types. Each one has its own fanboys out there on the internet. It is totally impossible to cover all the file systems out there with the limited time I have for this video. Linux also supports volume management. Some file systems have it built in, LVM, RAID, etc. At various times, some file systems have been more popular than others. Linux does include some compatibility, I already mentioned this, with the FAT and NTFS file system. Probably the most currently popular is the extended file system, or EXT. Like FAT, this has gone through several evolutions with increasing drive size. The current version is EXT4. Has journaling, it was developed in 1992. It supports journaling, supports permissions, disk quotas, encryptions, etc. So it is a modern file system. Other one I want to mention here, and again, I'm doing file systems I'm familiar with. If I don't mention your favorite, it's probably because I'm not familiar with it, although I do mention a bunch and a couple of additional ones I've even worked with next. High performance file system, XFS. This is a journaling file system with parallel input-output. It has a reputation for having slower data transfer rates, although this can be resolved with delayed logging. What XFS is famous for is high data transfer rates with larger files. Unlike ext4, it can't be resized and journaling cannot be disabled. That may or may not be an advantage or disadvantage to you. Yeah, I said Linux supports multiple file systems. Just a quick search of the internet turned up a whole bunch. These are not, by far, not the only ones. I know there's a couple missing here that people are going to say, why aren't you covering these? But just stay with me. Minix I've used once or twice. It's an old Unix file system with, well, it's a port from Unix without some of the more complex features of the Unix file system. I've actually used JFS a few times. It's more or less equivalent to EXT. I've never used the Riser family, Riser 4 or Riser FS. F2FS is an interesting file system. It's designed with NAND flash storage in mind, which means it limits the number of writes to reduce wear and tear on your NAND flash. If that's a concern to you, this might be an option for you. NILFS, log structure file system using circular buffer techniques. FXFS, NWFS I've used before a long time ago when I was doing some work with knitware. It's an equivalent to ext3. Other one I want to mention here is CEPHFS. This is an object storage file system. If you do Proxmox in any way, you'll probably see this. It will allow you to create a storage system that not only spans multiple drives in your computer, but multiple drives across your network. NASAN has similar features, but yeah, this one will allow you to have this one will allow your hard drive to actually be on a different computer and combine with the hard drive on your current computer. It's kind of an interesting concept. And like I say, if you do Proxmox, that file system's there. Again, I talked about the ones I've actually used. Some of these I've never used, but just a quick search of the internet showed these few file systems. There are lots more. I do admit that in some cases you get into fairly obscure territory, however. Now it is time to talk about volume management. LVM is strictly a volume manager. We've already talked about this one. Some volume management solutions include their own file system, and this is going to be those two file systems. I said people are going to say, why didn't you talk about these? We will. RAID, redundant array of inexpensive disks. This is another type of volume management. Uses multiple disks for error correction and fault tolerance and data recovery. It does require multiple disks. You need at least 2 to set up any type of array, usually more, depends on the type of array you set up. Data protection relies on the use of some space in your drive array, so you don't get the full space of all your drives, because generally at least one drive will be used for either mirroring or parity for fault tolerance. If you want to know more about RAID, I did a video on manual RAID 5 from the Debian terminal. I'll link it above. It does go into the various types of RAID, the number of hard drives required, and various other functionality. Now, file systems with volume management, the all-in-one systems. 2 most popular right now, not counting RAID, is BTRFS. Well, RAID doesn't actually fall in this category. It's not a file system. Anyway, BTRFS or ButterFS and ZFS are probably the best known. They both support RAID configuration. They have all the standard and advanced features, and they all have their own set of tools. Because these are a file system and a volume management, you can do snapshots and all the other tools that go with volume management. And these 2 are pretty popular nowadays. In fact, I think BTRFS is now the default Fedora file system. If you go with the default, you'll get BTRFS. Let's do an example. Let's say you have a Windows laptop with a single drive. As it comes from the factory, it will have bought within the last 5 years, a fairly modern laptop. It will be GPT. It will have an EFI partition. It'll have an MS recovery partition. It will have a recovery partition that the manufacturer put there, and then your Windows partition, which may or may not take up the rest of the drive space. You can always shrink a Windows partition if you want to add extra partitions. This is the laptop you buy from a manufacturer with Windows pre-installed, probably also similar to any desktop computer you buy with Windows pre-installed. Nothing fancy, nothing weird. All right, talking about something fancy and something weird, we're going to do a computer that's dual boot with 2 hard drives. And this is similar to the setup I've been using for a while. So again, new computer, GPT with EFI partition. You've got your MS recovery partition. You'll notice no recovery partition here. Once my warranty expired, I ditched the Windows operating system that came with it and loaded one straight from Microsoft, because the manufacturer's operating system had a bunch of bloatware in it that was available from the manufacturer's site for download. I did save the partition data and create an ISO on a USB stick in case I need it sometime in the future, but it's not on the computer. I recovered that space. Windows, have a Windows partition, and then we have an Arch Linux partition. To dual boot, you need to install Windows first, because Windows bootloader does not like other operating systems. But if you install it first, then you install Arch, you'll probably use Grub, which is fine with other operating systems. We also have 2 swap partitions, which was a mistake on my part, separating them. This is actually a good thing to do if you have mechanical drives, because it increases access speed, but any speed increases are very minimal with the solid state drives, which I'm using. Anyway, then I formatted the rest of the first or installed hard drive with the data partition and then a storage partition. Since these are accessed by Windows, they had to be NTFS. Going to Windows, if you remember, in Windows, you've got files like pictures, videos, music, documents. If you right click on those files, you have a location tab in the properties. I pointed them. Documents went to my data partition, and videos, music, pictures went to the storage drive. On my storage drive, I put stuff I'm still accessing but not reading, writing very often, and data drives where everything I work on goes. And once I finish up a project, it gets moved to an archive folder on the storage drive and eventually off the computer and onto my network backup server. Well, it gets moved there pretty quickly, but eventually I take it off of here and just save it there. But this is a bit more of a complex dual boot setup. I might actually do something on dual booting later, we'll see. Now let's create a similar sort of system using Logical Volume Manager. We have to have our EFI partition. It resides outside of the logical volumes And then the rest of the first drive is a LVM Physical Volume 1, and the entire second drive, LVM Physical Volume 2, which again gives us our volume group 1. And I put one swap partition up there, along with my Linux, my data, and my storage. This is not a dual boot. This is just Linux, and this is what the layout would look like. I would, depending, and there's a few decisions I have to make if I go this way with my current laptop. Do I want to fill up the entire volume group with the storage and data, or do I want to leave space open? This is going to depend. I still need Windows, so I'll be running it in a hypervisor as a virtual machine. If it's a type 1 hypervisor, I will need space for a Windows partition. Will actually be a type 1 hypervisor partition with Windows installed on it. If I use something like VirtualBox, I'd go ahead and expand these out because VirtualBox uses a file as a virtual machine. But this is basically what it would look like using LVM. Okay, I may have fibbed a little. I'm going to do a little computer stuff here. Got to do a little computer stuff, you know? So this is my Linux Arch installation running KDE Plasma. I'm going to open the KDE Partition Manager here so we can see my actual drive partitions. And here's the KDE Partition Manager. We can see our two M2 drives listed up here on the side, and we can see in the what's on them. So let's start with the main drive. You can see you have the FAT32 EFI system partition. Then we have the Linux swap partition. Then we have the unknown partition, which is actually the Microsoft Reserve partition. And this is our NTFS partition that holds our Windows operating system. And then this is our Linux partition. It's ext4 that holds our Linux operating system. And then finally, the rest of the drive is taken up with our data partition. Now, if we flip over to the other drive, it's got two partitions. We can see we have a Linux swap partition and we have our storage partition. In our home folder, and you'll notice these files like downloads, documents, music, pictures, etc. These are linked files. And if we look at the properties, we can see where they're actually linked to. It's a what they call a link in Linux. It's in my home folder, but it actually points to folders in the /srv directory. They're represented that way in Linux. They're represented a little differently in Windows. They're represented a little differently in Windows. Speaking of Windows, let's jump over to the Windows side of the house. Let's go ahead and search for partition, and we can find our create and format partitions in Windows. This opens a similar type of tool, and we can see all our partitions listed here, just as we saw them in the Linux side. Incidentally, you won't see these partitions in the file manager. Partitions like your system partition, my system partition, my swap partition, my non-NTFS partitions, you're not going to see, but they're there. And you'll notice you also see which ones have drive letters and which ones don't. But this is basically the same scene shown through Windows. And if we look in Windows, our directory, we can see, let's take our documents directory, for example. We open it, we have a location tab. And we can see this is not located on the C drive where my home folder is. Same with pictures. This one's on the E drive. So you can see it's a little bit more complicated than your straightforward Windows setup. Okay, that's the end of another video. I hope it was helpful. Hope it gave you something to think about. Again, we talked mainly about drives, partitioning, and file systems, although the video was mainly about file systems. So I hope I've given you some thoughts on what file system to choose or what you may want to do if you switch to Linux. Next video, I have my choice. I was thinking of one of two ways, either talking about the Linux file system versus a Windows file system or layout, which is something you're going to need to know if you're switching, or I was thinking of doing one on actually partitioning a drive and then adding file systems to it, which would be more of a actual hands-on. I'll have to think about which one I want to do. If you got any thoughts, let me know which way you want to go. I'm going to do both of them. It's just which one I do first. But again, the basic purpose of this video was to discuss a lot of the file systems available. We didn't go into them too deeply because it gets a little technical. Each actual file system is probably worth a video on its own. And a lot of them I haven't used. If I wanted to really do them justice, I have to give them a try for a couple of weeks and see how they worked. But again, hope this gave you some things to think about if you're thinking about switching to Linux. And again, click the like button, subscribe, leave a comment. I love comments. And we'll see you in the next video, okay?